Hello friends, welcome to ACE Live Solutions for SSC JE Mega Mock Test. And myself Sriram. And I'm here to give you the solutions for basic electronics paper, right? And see the first question. The common mode gain of differential amplifier is 0.1. And its common mode rejection ratio is given in decibels, that is 60 dB. The differential gain of the amplifier will be. This is quite common question in class. In the live class also, recorded class also, I have given n number of questions on this model, right? So, the differential gain, common mode rejection ratio, CMRR, is equals to differential gain by common mode gain. You know this, right? And he has given, you see, common mode gain value as 0.1. You need to find the differential gain at 60 dB of CMRR. Convert these 60 decibels into number, given is in decibels, okay? You will get 10 to the power of 3. 60 is equals to 20 log base 10 CMRR, right? So, the CMRR is equals to 10 to the power of 3. Am I right? 60 by 20 and 10 to the power of 3 is equals to CMRR. Then if you substitute it here, the differential gain AD is equals to 1000, 10 to the power of 3 into 0.1, right, by 10. That is equals to 100. Option A is correct answer. Simplified circuit of an amplifier, because here coupling capacitors, emitter resistor, emitter bypass capacitor, all are actually modified, ignored. Strictly speaking, it is not a final AC circuit but modified circuit, partially simplified circuit, except DC power supply. Thermal equivalent voltage is given. He is asking about the approximate voltage gain. To find the gain, we have different formulas. From RE model, we have some formulas, pi model, okay, H model. But clearly we can understand as per the given data, current is provided, collector current, DC biasing current is provided, and thermal equivalent voltage is also provided. So, we can use this formula. Voltage gain AV is equals to minus GM into RC. But we don't have RC alone. In this amplifier, we have RC as well as RL. So, GM into RC parallel RL. So, what is a transconductance GM? IC by VT. Strictly speaking, IC DC by VT. What is a IC DC? DC collector current divided by thermal equivalent voltage. So, that is why AV is equals to minus IC 1 milliamperes divided by 25 millivolts thermal equivalent voltage VT into RC value 2K, RL value also 2K, and 2K parallel, okay. This is 1 kilo ohm. Then you will get the approximate gain, of course. AV is approximately equals to minus, see 1000 by simply 25. You can directly select minus 40. Minus 40. Identify the type of negative feedback topology in the circuit shown below. The question is given very clearly, negative feedback. Feedback means negative, while we are only giving or finding topology, shunt, series, shunt, or voltage control, voltage source, voltage control, current source, current control, current source, current control, voltage source, based on how the feedback network or elements are connected at input and output, how they are sampled and mixed. By look at this, directly students are applying the shortcut. Sir, this is a feedback network connected at input, indirectly at output, directly connected the output node, or if I connect ground to the output node, it is going to be 0. So, it is a voltage sampling. So, like that they are giving like it is a series and a shunt type of a amplifier. Okay, like that students are doing their own analysis. But first of all, given is not a amplifier. D is the correct option. None. Shunt, series, shunt, all are wrong. None of the above is correct. Why? Because if you observe carefully, this is not a negative feedback amplifier. Given is a positive feedback system. In positive feedback, even we can't call it as amplifier. It is not an amplifier first of all, right? It is a Schmitt trigger. Do you remember this circuit? Schmitt trigger. Schmitt trigger. Standard resistors values are R1 and R2. This is a feedback, right? And we are providing some time dependent signal here, some sinusoidal or some random signal. So, given is a positive feedback type system, it is not an amplifier, that is enough. Indeed, this is first of all, this is a Schmitt trigger, it is not an amplifier to decide the type of feedback. That is why D is the correct option. In a clipper circuit, forward bias resistance of a diode, it is a practical circuit, okay, 36 ohms. And in reverse bias, what is the diode resistance? It has to be infinite under ideal, but practical case, VLV will be in the order of mega ohms, 1 mega. Then the best value of a series resistor of the circuit, we have a standard formula for this. Rs is equals to square root of forward bias resistance of the diode into reverse bias resistance of the diode. That is equals to 36 forward bias resistance, that 36 ohms into 1 mega, 10 to the power of 6 ohms. So, what is the Rs? Root 36 into root 10 to the power of 3 whole square, 10 to the power of 3 kilo, square root get cancelled, root 36, 6 kilo ohms, na? 6 kilo ohms, right? 6 kilo ohms is the correct answer. Be careful, 6K, right? 6 kilo ohms, 10 to the power of 3 whole square. Square root get cancelled, 10 power 3 will becomes kilo. Thermal runaway occurs in MOSFET, we don't have thermal runaway, maybe catastrophic effect, but we don't have thermal runaway. Thermal runaway occurs in transistor, bipolar junction transistor, that too in common emitter configuration, due to the cumulative effect of temperature and leakage current. Finally, operating point will place in the saturation and the device enters into deep saturation. The device may damage sometimes, right? So, that phenomena is known as thermal runaway, but little big story we have discussed in the recorded class, right? But finally, resistor, diode, MOSFET all are wrong options. In intrinsic semiconductors Fermi level, semiconductors can classify into 3 types: intrinsic semiconductors and extrinsic semiconductors. Extrinsic semiconductors, again, do you remember? 2 types, N type and P type. And in N types intrinsic semiconductors, the Fermi level lies on at the center of the energy band diagram. In N type semiconductor, Fermi level will be near to the, this is reference, okay, this is EFN, near to conduction band or move away from the center. In P type semiconductor, the Fermi level lies at near to valency band. This is the reference and this is EFP, Fermi level in P type semiconductor. This is an intrinsic semiconductor at the center of a energy band diagram. He is asking about intrinsic semiconductor, middle of the energy gap, right? And which of the following is a correct relation for number of electron holes? What is the number of electron hole relation according to the mass action law? I think you remember that N into P is equals to Ni square. Ni indicates intrinsic constant. So, from the options we can write Ni is equals to square root of N into P. B is the correct option. What is the value of current I in the circuit? Students are trying to write node equation at this point, no. This is a closed loop inverting amplifier, okay. This is a closed loop and inverting amplifier, and virtual short is applicable. Op amp is what? Ideal. Virtual short applicable. And gain not provided means infinite, you consider open loop gain. Current entering into op amp is how much? In ideal case, 0 amperes. Under ideal conditions, current entering into op amp is 0. So, this is the current I if you assume, let us say Ix. The same amount of current will pass through this branch also. The amount of current passing through this branch and this branch will decides the output voltage, but I don't care, because my task is not to find output voltage, my task is to find this current I, okay. So, this I is equals to Ix is equals to 5 by 1k, 5 milliamperes, 5 by 1k, 5 milliamperes, yes, option A. The output voltage V0 of the circuit shown in figure is, don't worry about it, the output voltage V0 of the circuit shown in figure is, what is the output voltage V0 here? If you observe carefully, this operational amplifier is in closed loop, okay, and what is the name of this circuit? Voltage buffer. Given is a voltage buffer. Output voltage is same as input. So, from here what is a Vx? That is equals to 5 volts only. So, you don't need to worry about amount of current or internal resistance of this output op amp, output resistance, no need to worry about it. Just it is in closed loop, negative feedback, virtual short is applicable. In that case also it is 5 volts, that is all. If this is 5 volts, voltage drop across transistor not provided, but we have solved so many problems in this model. If no data provided, by default what I told you, 0.7 volts. Of course, in any material also you can find the same thing, 0.7 volts drop across VBE, 5 minus 0.7. V0 is equals to 4.3 volts. V0 is equals to 4.3 volts. Right, guys? Please verify the solutions. Right? Please verify the solutions. And my friend will continue the next subject. And I will change the slides meanwhile. Please verify your solutions.
Hello, my dear students. I hope your preparation is going very well. So here I am with the most accurate solutions for the mock test what we have conducted, and the correct standard of SSC JE paper is what I gave. Now let us have this discussion with video solutions on this SSC JE mock test. Okay, myself B.S. Krishnarma, faculty in ACE Engineering Academy and ACE Online since 2009. Okay, so as you know, this electric circuits part A, and also it has got magnetic circuits, it's a bulk. So I gave such a paper where almost 29 bits, and that is a real weightage of this subject. And I gave exactly relevant questions at that standard what is required for SSC JE. So you can expect the paper standard to be this way. So prepare everything and all the best. So I am going with video solutions here. Now see this first question. The power factor of certain passive network with equivalent impedance and applied voltage. Now in my linear subject, power factor you can find in many ways. Okay, one is cos of phase angle between voltage and current, one is R by Z, one is P by Z. When already impedance is given, I need not go for power triangle and phase angle, right? Directly impedance angle. So directly power factor is R by Z. What is resistance here? 3. But what is impedance? Root of 3 square plus 4 square, root 25, 5. So 3 by 5. What is 3 by 5? 0.6. But leading or lagging? Now see, reactance positive. Reactance positive means inductive. Reactance positive means inductive, power factor is lagging. So answer is 0.6 lagging, 0.6 lagging, option B. Okay, simple. Impedance triangle is faster in this case. Now let us go to this. The unit of reactive power. What is the unit of reactive power? Volt ampere reactives, volt ampere reactives. We have 3 types of power. real power in watts, reactive power in wars, volt ampere reactives, apparent power in VAs, volt amperes. So reactive power is volt ampere reactive. That is the rate of change of electromagnetic stored energy in inductor and rate of change of electrostatic stored energy in capacitor in AC circuits. Then the theorem which states that for linear system, the response, that is voltage or current in any branch of a bilateral linear circuit having more than one independent source is equal to the algebraic sum of responses caused by each independent source acting separately. Is which theorem, sir? Additive property. So the effect produced in any element or network when all sources act at a time is also equal to sum of individual effects. Is which theorem? Additive property, superposition theorem, superposition theorem. Thevenin's and Norton's are reduction techniques. Milliman's also reduction in parallel generator form. So which theorem will give this? Sum of individual effects is total effect is additive property, superposition theorem. Okay. Now, in Norton's equivalent circuit, all current sources can be replaced by single current source in parallel with resistance, because Norton's equivalent consists of current source in parallel with resistance. So that is that. Thevenin's what? Voltage source in series with resistance. Norton is current source in parallel with resistance. This is called Norton current. So current source in parallel resistor is the answer. Simple. Okay. Then a network has 10 branches. So branches are 10. And it has got 4 independent. Of course, independent loops are meshes. Independent loops are meshes. Then how many nodes are there in the network? How many nodes? So we know meshes equal to branches minus nodes plus 1. Meshes are 4. Branches are 10. So now nodes is asking. Nodes is 11 minus 4, 7. So nodes are 7. Option B. Simple na sir. Meshes equal to branches minus. But these independent loops are called meshes. Be careful. Okay. Then inductors and capacitors are energy storage elements. Okay, they are circuit elements, they are amplifiers, they are power elements. No, they are energy storage elements. They store and release. Okay, because active power is 0, power elements you should not call. They never amplify. Okay, they are sinks, globally sinks. Circuit elements is general meaning. Okay, but energy storage elements is the relevant answer. A relevant answer based on this, the best option is storage elements. They store and release energy. A 10 Henry inductor changes current by 4 amperes in 0.5 seconds, the voltage induced. Now we know according to Ohm's law, V is L di by dt. L is how much? He said 10 Henry. Okay. Then change in current delta is how much? 4. In how much time? Half second. So simple. This is 8 tens are 80 volts. So the value of the voltage induced is 80 volts from Faraday's law. Okay. That is also, of course, applied voltage V is L di by dt. Induced is E, but magnitude wise same. Okay, magnitude wise same. You can also write magnitude wise same. Okay, answer is 80 volts. Now quality factor. Now quality factor, does it have dimension? Maximum stored energy by energy dissipated, both energy. So quality factor is 2 pi into maximum stored energy by energy dissipated. So this is dimensionless. Okay, it is dimensionless. It is a constant. Quality factor is a constant. Okay, there is no unit for it, dimensionless. Now the resistance seen in the circuit. Now if you see, I want equivalent resistance. Now these 3 branches are parallel. Na? 3 plus 3, 6, 6, 6 parallel. Resultant is how much? 6, 6, 6 parallel is 6 by 3. 6 by 3 is 2. 2 plus 2 answer is 4 ohms. 2 plus 2 answer is 4 ohms. Then 2 waveforms are represented. Now their RMS values they are comparing. See, first of all, this is omega, 3 omega, 5 omega. Omega, 3 omega, 5 omega. So this is Fourier series concept. Now RMS values of such is independent to phase shift, negative, positive, frequency. Because it is Fourier series. Now what is the RMS for the first thing? Root of. Okay. Fundamental component 10 by root 2 square. Okay. Here also 7 by root 2 square. Here also 3 by root 2 square. And what about the second waveform? Here also root of fundamental component 10 by root 2 square. Here also 3 by root 2 square. And then again 7 by root 2 square. So both are same. So in such case, see for AC positive negative, this only minus plus creates phase shift. They only tell phase shift of the signal. You can write in terms of cos and sine. Phase shift will only tell whether the signal is coming early or late, but RMS will never change. So yes, RMS of both will be equal. Both will be equal and non-zero. So RMS of both will be equal and non-zero. Okay, or non-zero and equal. Okay, now that is the answer you see. Okay, then a 1000 ohm resistor is in series with 2 million inductor and it is subject to a voltage source of frequency this much. Then what is the impedance? Now we know impedance is R plus J XL. That is nothing but R plus J omega L. R is how much he said? Okay, 1000 plus J omega. Omega is how much he said? 1 lakh. 1 lakh into L. What is L in the circuit? 2 milli. 2 into 10 to the power of minus 3. So remove milli and this confusion. So it is 1000 plus J into 200. 1000 plus J into 200. Yes, answer is B. Okay. Yes, impedance is R plus JXL omega L. Okay, 1000 plus J into 200. Now let us come to this. Now in the circuit shown V0. Okay, circuit shown V0. Let us do nodal. That is the fastest way. I will do nodal analysis here. Now V0 minus 36 by 3 plus V0 by 6 plus V0 minus 6 by 6 is 0. Now if you take LCM 6 2 times, so total 2 plus 2, 4 V0 is 78. So V0 is 78 by 4, around 19.5. Yes, 78 by 4. Almost like think na sir. See calculator, 80 by 4 is almost. See 78 nearest is 80 by 4 is 20. Near to 20. Near to 20 is this 19.5. So no need of calculator. The power dissipated by 90 ohm. Here he is asking power dissipated by 90 ohm. See if you observe with respect to reference, this is already 100 volts. This is already 60 volts. What is the potential difference coming here? 100 minus 60, 40 volts. So with respect to reference, this is 100, this is 60, difference is 40. So power is V square by R, V difference square by R. So this power is V difference square, that is 40 square by R. R is 90. So remove this, that is 40 square by 90. Okay, that is nothing but you see 160 by 9. 160 by 9 nearest to 2, nearest to 15, okay, 18. Yes or no? 160 by 9 is greater than 16, so nearest to that is 18. Yes or no? See, because V square, that is 40 into 40 by R, V square by R. Okay, V square by R. Okay, that is 160 by 9, which is 18. Okay, then you will get 17.7 something, but nearest is that. Okay, now in the circuit shown at steady state, all circuit elements, okay, all circuit elements, what is the energy stored in 2 Henry? Now in steady state, see this is DC steady state, sir. For DC steady state, capacitor open, inductor short, inductor short. When capacitor is open, this side will not work. Okay, so that only this part will come. This is 24. Of course, 2 resistors in series 9 and inductor is short. This is 24, inductor short. Then what is the energy in inductor? Half L I square. Half. L is how much he told? L is 2 Henry. I square is how much? I square is how much? I is 24 by 9. See, 24 by 9 square. That's it. So this is 24 into 24 by 9 into 9. Okay, 3 8s are 3 3s are. Here also 3 8s are 3 3s are. So 8 8s are 64 by 9. 64 by 9 if you see. Yes, 9 7s are 63. 7.1. 7.1 joules. 60, you see 64 by 9. 63 is 7, 64 by 9 is 7.1 joules. Simple, sir. Okay, you will give such bits in. At ideal battery, there are 3 resistors are assembled in the circuit. What is the current flowing through the battery? Now current flowing is total current. Now this total resistance is 4 parallel, 2 plus 2, 4 ohms. Chalo, 40 by 4, 10. 10 will go and 10 has to come back. That is law of conservation of charge. Whether he is asking here or here, same. Because total current will go divide and again come back. So 40 by 4, 10 ampere. 10 ampere has to come back. So answer is C. Answer is C. Okay, simple Ohm's law. Now he is asking the equivalent resistance where each branch resistance is 10. Now if you observe, sir, first of all, this is shorting this element. Because this is single node, watch this. Okay, if this is single node, this is shorting this element. And all resistors are 10. Now if you short this, you see very interestingly, this is 10 10. Okay, that I am not disturbing. Here also this is 10 10 in parallel, that also I am not disturbing this part. But here by shorting this, see, by shorting this 10 and 10 become parallel. So finally this is 110 and this is 110, but this is shorted. This is shorted. So this is the meaning. So don't confuse with short circuit. This short circuit, if I knot it, this short circuit will short it. But this is single and this. So now if you see, this is all 10, 10, 10, 10, 10 and 10. Now watch this. These 4 elements all are 10, okay, all are parallel. 4 10 ohms parallel is how much? 2.5 ohms. Okay, 4 10 ohms parallel is 10 by 4, 2.5. And this 10 10 parallel is 5. So finally 5 plus 2.5, 7.5 ohms. It is simply 7.5 ohms. But only trick I gave is short circuit. There is a short circuit shorting this element, not this element. If you bring here this is short in this. So 10, 10, 10, 10 parallel, 10 by 4 is 2.5, but this 10, 10 parallel 5, 5 plus 2.5, 7.5. Now here he is asking a circuit with two terminals. The Thevenin's equivalent is asking. What is Thevenin's equivalent, sir? First of all, Thevenin's resistance. Open current, look from here, 3K, 3K, 6 kilo. Then what is Thevenin's voltage? Open circuit voltage. That is I into R. That is nothing but 30 milli into R, 3 kilo. So this is clearly 90 volt. 90 volt in series to 6 kilo. 90 volt in series to 6 kilo, option D. 90 volts in series to 6 kilo is option D. Okay, Thevenin, simple. Now, a circuit consisting of 4 resistors as shown. He is asking the value of voltage V across 7. Now what I will do, first I will find total resistance. Watch this carefully. Though he gave inductor in DC steady state, inductor is short circuit or not? Yes, in DC steady state. So what is the total resistance in? That is nothing but first these two in parallel. So that is 12 plus, okay, 4 in parallel to 12. That is 4 into 12 by, yes, 16. This is nothing but 4, 3. So 15 ohms. Yes or no? Total. Then what is the total current? Total current is 120 by 15. Yes or no? That is nothing but 120 by 15 you will get. That is 88 amperes. Now I will find this voltage by current division rule. This voltage is resistance into current. That current is total current into opposite 4 by sum. 4 plus 12, 16. 16. So this is nothing but 14 volt. 14 volt is the answer. 14 volt. See what I did, I will explain again. He is asking this voltage, sir. So first to get this voltage, I try to find the current in this. But to find the current, first total current. Total current is total voltage by total resistance. Inductor is short circuit in DC, don't worry about that. So total resistance is 12 in parallel to 4 plus 12. Okay, this is 12 in parallel to 4 plus 12, 15. So 120 by 15, 8 amperes. But current division rule in these two parallel branches, that is open. So this current is total 8 into opposite 4 by 12. Okay, this current is total current opposite by 12. That current into resistance is voltage. So answer is 14. Simple Ohm's law, current division. Ohm's law, total voltage by total resistance, total current. Then current division and Ohm's law. Now the switch in the circuit has been opened for a long time and there is no initial current, there is no initial charge. It was open at long time. Now the switch closes at t equal to 0, then the steady state voltage across capacitor. Now when the switch closes in steady state for DC, capacitor acts as open circuit. In steady state DC, capacitor acts as open circuit. So this is the final circuit in steady state. These two are there and this is open circuit. Capacitor is open circuit. Now clearly this is how much? 40 volt. This is 2 kilo ohm, 2 kilo ohm and 4 kilo ohm. Now I want this open circuit voltage V of infinity, steady state. Now can current flow here? No. These two are equal in series. So voltage division, this voltage is total voltage into same by sum. So answer is 20 volts. Answer is 20 volts. 2 equal resistors. Answer is 20 volts. 2 equal resistors. Answer is 20 volts. Okay. Now see this interesting question. A balanced delta load is shown, is connected to a stable 3-phase voltage source. Okay, stable 3-phase voltage source. The RMS line voltage is 120. The RMS line to line voltage is 120. Then RMS magnitude of line current is asking. So in delta we know line current is √3 times phase current. In delta, in a balanced delta, line current is √3 times phase current. Okay, but this phase current is nothing but phase voltage by impedance. Phase voltage by impedance. Okay, it is phase voltage by impedance. Now if you observe, but in delta line voltage itself is phase voltage. Line voltage itself is phase. So line voltage is how much? 120. Impedance per phase is how much? 15 plus J10. 15 plus J10. That is nothing but 120 by impedance magnitude. 15 square 225 plus 10 square 100. So √325. 120 by √325. Okay na? Yes. You will get this as somewhere 18. So 120 by 18. That is 6.667. Approximate, sir. √325 is near to 18. So 120 by 18, 6.667. But I want line current. Line current is √3 phase current. Okay, √3 phase current is 6.667 into √3. But √3 increases by 1.732. That is increased by almost 75%. So it is already 6.66. Increased by another 5, near 11 point something, approximate, because √3 is 1.732. Increase almost 1.732 means increase by 70%. So almost approximately 70% of this is 5 point something. So total 6 plus 5, 11 point something. Yes, I think this is the answer. This is the answer. So in a SSC JE, the bits are like this, sir, no calculator is allowed. Okay. So first of all, line current is root 3 times phase current, but phase current is phase voltage by impedance. In delta, phase voltage and line voltage are same in delta. So phase voltage and line voltage, but impedance is 15 plus J10. But 15 plus J10 magnitude is how much here? Phase angle he did not ask, sir. So root of 15 square plus 100 square, root 325. Root 325 is near to 18. So 120 by 18 is 6.667. Now 6.667 into root 3 is somewhere around 11.5. Okay. So now he is asking the resonance frequency. Yes, resonance frequency omega naught is 1 by root LC. Series RLC, 1 by root. L is how much? 2. C is how much? 1.5. 3 by 2, 10 to the power of minus 6. So this is 1000 by root 3. 1000 by root 3 is near to 577 point something. Because decrease by 7, 1000 by root 3. 1000 by root 3 is this only, na sir. 1000 by 3 is near to this. 1000 by root 3 is this. So based on the answer, the nearest answer. Okay, 1000 by root 3 radians per second. The process in which change in current in one inductor induces voltage in nearby inductor is mutual inductance, mutual voltage, mutual inductance. Yes, sir? Change in current in one coil will induce EMF another mutual. Then if the magnetic flux caused by the current in one coil links with the other coil, thereby inducing voltage, this phenomena is called again mutually induced EMF, mutual inductance. Not mutual insulation, mutual conduction, mutual capacitance, no, mutual inductance. Then the equivalent inductance. Now tell me, these two coils are series aiding or series opposing? Suppose if current goes this way, here current is entering the dotted terminal, here leaving the dotted. One entering, one leaving is mutual opposing. So mutual opposing, L total will be L1 plus L2, all are in Henry, L1 plus L2 minus 2M, M is how much? 50. So yes, this is 150 minus 150 plus 50, 100 Henry. Answer is 100 Henry, option A, 100 Henry. Okay. Then now these are very interesting. A parallel resonance circuit RP L and C and a series resonance circuit RS L and C have same quality factor. Then the relation between RP and RS. Say quality factor of series is how much? R series root 1 by R. Okay, let me write neatly. Okay, if you go with, okay, let me correct it. Chalo. Now if you go with parallel, first series and parallel, na? Yes. If I go with that, everybody watch this. Now in series resonance is 1 by R series root L by C. Parallel quality factor is RP into root C by L. Okay. Now he said both are equal. Both are equal. So if I equate both, chalo, if I equate both, what I will do? Yes, 1 by R series root L by C, okay, is RP, okay, into root C by L. But he is asking both these quality factors are same. So now let me write in terms of quality factor, but both let us write. Here what is happening? So here also let me write like this, okay. So one way quality factor of series is 1 by RS root L by C and quality factor of parallel is RP root C by L, okay. Now in this, if I write root L by C, what it happens now? Root L by C is, okay, RS into Q. RS into. Now let I substitute here. So this Q is RP into root L by C is this. So root C by L is 1 by RS into Q. Chalo, from that I can write RP is quality factor square into RS. RP is quality factor square. Okay. So if you observe, RP is quality factor square into RS. Okay. Here in my slide it came Q2, but actually it is Q square only. But RP is, see sir, simple. Quality factor of series RLC is what? 1 by R series root L by C. Quality factor of parallel is ulta of it. RP root C by L. But both are equal. But from this first root L by C is how much? Root L by C is RS into Q. And that I am substituting here. But this is root C by L. So 1 by this. So if I equate, I am getting this. So RP is quality factor square into RS. Of course, in my slide now, this Q square I wrote like this. So it is B, option B. Okay, not this. These two cannot be the answer. This, option B. Now see, two coils connected in series have an equivalent inductance of LA. Okay, if the connection is aiding, then equivalent inductance LB if the connection is opposing. Find the mutual inductance. So he said that two coils in series. Now what is LA? LA is L1 plus L2 plus 2M because series aiding. Then what is LB? L1 plus L2 minus 2M. Now you want mutual inductance. Now subtract, directly subtract. LA minus LB is, this will cancel, 2m, 2m, 4m. From that what is m? M is LA minus LB by 4. LA minus LB by 4. LA minus LB by 4 is option D. Okay, LA minus LB by 4 is option D. Now you want total inductance. Now this is very interesting, sir. Okay, total inductance. If secondary was open, secondary wouldn't have influenced primary, then L equivalent would have been 5. But secondary is shorted. Now, if you simplify this into T model, you take mutual aiding or opposing. If you simplify this into T model, see sir, if you simplify, first let me write like a formula. If you simplify this into T model, okay, yes, in T model, let me correct it. Okay, this is very interesting, sir. In T model, first let me write, so that this is a universal question. I am expecting such things to happen now. Yes, if you write this in series aiding or series opposing, same answer will come. Because inductance is passive bilateral. You may say, sir, dot is given, what about dot? Because inductance is passive bilateral, independent notation, you take mutual aiding or mutual opposing, same will come. If I take mutual aiding, this is plus m, this is L1 minus m, this is L2 minus m, secondary is shorted. Now what is L total seen from here? This plus this in parallel to this, L1 minus m plus these two in parallel, that is ML2 minus m square by this plus this, by L2 by L2. You remove this, so this is L1 minus m square by L2. L total is L1 minus m square by L2. Now you take mutual adding also, mutual opposing also, same answer will come. But in mutual opposing, this is minus m, this is plus, same answer will come. Because inductance is passive bilateral. So now this L total is L1 minus m square. L1 is how much? 5. Minus m square is 3 square by L2. L2 is 3. So it is 5 minus 3. Answer is 2 Henry. Answer is 2 Henry. Option B. But very important, sir, T model reduction is coming. And moreover, secondary short. So very interesting reduction technique. Okay. Then the mutual inductance between two coils having self-inductances of 40 and 90 micro with 40% of flux producing coils link each other. Now that means K is 0.4. 40% common na, K is 0.4. Then what is the total inductance? Mutual inductance, self-inductance. Chalo, linked each other. So automatically this M is equal to K root L1, L2. K is how much? 0.4. L1 root, that is 40 micro. L2 90 micro. Okay, that is 0.4 into, chalo, this 10 you take it, 9 4s are 30, 60 micro. Okay, that is nothing but 24 micro Henry. Answer is 24 micro Henry. 24 micro Henry. Okay, 24 micro Henry. Then the equivalent inductance between two parallel connected coils with inductances and mutual. Now this is parallel system now, sir. L total will be L1 minus L2 minus m square by L1 plus L2 plus n minus 2m. But he did not mention aiding or opposing. But L1 L2 minus m square by L1 plus L2 plus n minus. If they are parallel aiding, more answer, put minus in the denominator. If parallel opposing, less answer, put plus in the denominator. So option is D. Option is D. Okay, option is D. Okay, so all the best. These are the most relevant expected questions. But at the same time, go through all my videos, all the models and do all the PYQs. AC Engineering Academy book is the most critical now. The AC Engineering PYQs of SSC JE, RRB JE are enough, sir. Okay, and these are relevant questions. Okay, all the best. Any doubts, etc. in our ACE Educator app, forward to me. I will always answer with all the best.
Hello everyone, let's see the questions from electrical machines here. See, the first question is, the ratio of full load slip to the no load slip of an induction motor will be dash. The ratio of full load slip SFL to the no load slip SNLet. So what is this ratio approximately? So from the options, if you see it is less than 1, more than 1, unity like this. First you should know, under full load condition, what is the slip and what is no load slip. Under no load, the motor always rotates very near to synchronous speed. No? Induction motor rotates very near to synchronous. Means if you take approximately synchronous, it is 0 slip. But it never rotates at synchronous speed, but near. That's why what is the slip at no load condition? Very, very less. But when load increased, the speed of the motor slightly decreases. When speed decreases, what is the slip of the motor? Increases. So no load slip is very less and full load slip is no load slip is very less and full load slip keep on increase. Means when load increases, slip increasing. So full load slip is more than no load slip always. That's why what is the denominator value? Very low, and full load value little bit more than this. Definitely the ratio will be greater than 1 it is. So full load slip is approximately, you can take 4%, 3% like that approximately, and no load slip is less than 1%, it is very near to 0, okay, 0.5% in that way, or let us take less than or 1%, let us take. Then what is the 4 by 1% means 4 only, so which is greater than 1 always, so more than unity it is. Next question. The maximum torque of induction motor is related to voltage and frequency as dash approximately. How maximum torque related? So we have some V by F ratios, starting torque, maximum torque. Remember, this maximum torque relation with voltage and frequency is V1 by F whole square it is, okay. So maximum torque related with voltage is square and also with frequency is 1 by F square. So V1 square by F square, which is option C it is. Next. The in-phase injecting it is. The in-phase injecting of EMF in the rotor of an induction motor is suitable for dash type of drive. So one of the speed control method for induction motor we use is EMF injecting method. So we have in-phase injecting, out of phase injecting. In the in-phase injecting method, we get which speed first, you should know that. So what is the speed we are getting for in-phase is above rated speed, okay, high speeds we get. So if you want to reduce the speed, then we go with out of phase injecting. So in phase, as speed increases, means above rated speed, high speed it is, which type of drive? If you remember the type of drive, torque power drive we have for above rated speed. This is rated speed, let above rated speed. In the above rated, power is constant and torque is varies like this. Now here above rated, no, which is that constant power, variable torque. Now you see that constant torque there, no, constant power, yes, variable power, no, constant current, no. So constant power is there, no, so that is above rated speed, constant power drive it is. Next, in order to produce maximum torque at time of starting, then the rotor resistance should be dash. At the time of starting, we need maximum torque at the time of starting. So to achieve this, what should be the rotor resistance? So we have one condition. If you want maximum torque at the time of starting, what is the condition? The rotor resistance should be equals to the rotor reactance. But is it directly equal? No, because rotor resistance is very small. So if you add some external resistance such that the total rotor resistance should be equal to rotor reactance, then we can achieve this. So total rotor resistance must be equal to rotor reactance. Option A correct for this. Next question. The main drawback of single phase single winding induction motor is dash. What is the drawback of single phase single winding? So we have generally in single phase induction motors two windings, main winding and auxiliary winding. Okay, auxiliary winding why we are keeping? To make it self start. But if there is only single winding, that is main winding without auxiliary winding, what is the drawback of that? See, even with one winding, the induction motor can rotate, but its drawback is it cannot be self start. It won't start itself, but it will, if once you give some external force to rotate at the time of starting, then it will pick up the speed. So under running condition, it is able to develop torque, but problem is only at 0 speed, it cannot develop any torque. Starting torque is 0 here. So the problem is it cannot be start, but can produce running torque it is. Okay, this is correct option for this. Next, the motor suitable for drilling. So which motor we use for drilling? Series motor, which produce high starting torque. So it is suitable, which is nothing but universal motor it is. Okay. Next, shaded pole, these are all very small torque applications we use, but for drilling we need good torque. So there we use universal motor. Next one, which of the following is a feature of hysteresis motor? If you see here, rotor with projected poles, no. Hysteresis motor will not have any poles in rotor. So it is a round rotor, okay, smooth surface will be there, no poles projected anywhere, and low noise, high resistivity, variable speed. Generally, hysteresis motor will rotate at constant speed with a very low noise. That is the main feature of this hysteresis motor. With a low noise it is. So noise during the operation is very, very less. Okay. So that is one feature of hysteresis motor, low noise. Next, a 12-pole 3-phase induction motor supplied at 50 Hz. Then the rotor EMF oscillations per second at 4% slip. What is meaning of rotor EMF oscillations? Nothing but frequency, rotor frequency it is. What is the rotor frequency under running condition of 4% slip? the rotor frequency is equal to SF directly. At 4% slip they are asking, means 0.04 into 50 Hertz, nothing but 2 Hertz it is, or 2 oscillations per second. So, answer is option B. Next, the synchronous impedance measured in EMF method to find voltage regulation is related to dash region. If you remember, no, one of the method to find voltage regulation is synchronous impedance method. So, in this method we get the regulation which is greater than the actual regulation, that is why we call it is pessimistic method. So, why it is giving more than actual regulation means the impedance calculated in this method is related to unsaturated region. Generally we have to find actual ZS. The actual ZS is always after saturation we get, after saturation. But before saturation the value of ZS will be little higher, that is why we get more regulation in that method. So, they are asking it is related to dash unsaturated region it is, okay. Active region actually that actual impedance related to after, just after saturation it is, not after so much time, just after. But that ZS actually is difficult to find practically, that is why in unsaturated region we calculate, that is why it will give the maximum or highest regulation among the methods we have. Next, a 6-pole 30 slots 3-phase alternator having 2 layer or double layer winding with each coil of 6 turns, then calculate number of turns per phase. First you need turns per phase, means you have to calculate first total turns how much, what are the total turns, that depends on coils in the taken. As double layer winding given, no? So, in a double layer winding concept we know the number of coils is always equal to number of slots it is. How many slots are there? 30 slots are there. Then how many coils will be there? 30 coils will be there. So, therefore, total coils are 30. Then what is the total turns? Given that each coil is having 6 turns, so total turns are 30 into 6, nothing but 180 turns it is, total it is. But they are asking turns per phase. So, as it is 3 phase, per phase means 180 divided by 3. Then we have the turns per phase is 60 turns it is, okay. So, 60, option B is correct. Next, which harmonics are possible to eliminate by using a short pitch angle of 30 degrees? So, we have some formulas related. What is the short pitch angle for 5th harmonic to eliminate, 7th harmonic to eliminate? What is the formula? 180 by n. If it is 5th harmonic, 180 by 5. If it is 7th harmonic, 180 by 7 and so on. But here they given directly some angle. The short pitch angle is alpha equal to 30 degrees. Remember, with this alpha 30, it is nearer to 5th and also 7th. If you find that angle, no? So, nearest angle it is for both 5th and 7th harmonic. That is why by utilizing this short pitch angle, we can eliminate both 5th and also 7th, which are the dominant harmonics we can eliminate. So, one more is there 3rd, that we can eliminate by using distributed case, distributed winding. So, here both 5th and 7th, that is option D. Next, an alternator supplying a load of 0.707 lagging, okay, 1 by root 2, 45 degrees. If the load power factor increase, then which effect of armature reaction decreases? If you remember now armature reaction topic, we have different load power factor, different reactions. Initially it is operating at some 0.7 lag. Now power factor increase means towards 1. When power factor increasing towards UPF, then cross magnetizing effect increase. And what is the demagnetizing effect? Actually it is in lagging, means demagnetizing effect will be there. But when power factor increase, demagnetizing effect decreases and cross magnetizing effect increases. But it is asking here which effect decreases, that is why demagnetizing effect decreases. Option B is correct here. Next, the maximum regulation of alternator is approximately possible at which load of power factor it is. Maximum regulation. Remember, maximum regulation always we get for lagging, okay. So, there are 2 options with lag here. Now, you can strike out these 2. Now, maximum regulation possible for lag near to which power factor? Near to 1 or near to 0 is near to 0 always, means 0.16, nearer to 0. No? So, near to 0, 0.1, 0.2, in that range we get maximum regulation. So, option D correct. An under excited synchronous motor with 80% of full load operates at which power factor? First of all, under excited motor operates at which power factor? Lagging. over excited motor operates at leading. So, under excited they are asking, so definitely it is lag. So, we have two options with lag again, this one and this one. So, which one we have to consider? ZPF lag means pure inductor. So, when a synchronous motor behaves as a pure inductor, that is under no load condition only, but given some load, 80% of load it is operating. So, definitely it is not at 0 power factor lag, some other lag. So, only one possibility is 0.7 lag. Next, the reluctance torque of synchronous motor does not depends on dash. If you remember the equation of reluctance power, which is V square by 2 into sin 2 delta into 1 by x cube minus 1 by xd. In that equation, we do not have EMF E, that is excitation voltage is not there. So, reluctance torque does not depends on the excitation of alternator. Even excitation changes, reluctance power will not change. Okay. So, that is excitation, option D is correct. During slip test or salient pole synchronous machine, the slip preferred for accurate reading of meters is dash. In the slip test, no, we use ammeter, voltmeter, okay, to measure XD and XQ it is. Now, what is the slip preferred for accurate reading? Because there meters will oscillate, because we rotate the rotor of that salient pole machine other than synchronous speed, less than or greater than, and which is preferred one? Definitely slip will be there. Slip is not 0 in this test, because we are not rotating at synchronous speed, slip will be there. Now, which slip we preferred is, there is 4%, 2%, minus 4, okay. So, we preferred always lowest slip. Lowest slip means very near to synchronous speed we rotate. If you rotate that rotor of salient pole machine very near to synchronous speed, no, then what is the slip? Almost 0 nearly. Then if you rotate very near, the meter oscillation speed also very slowly they oscillate, because relative speed is very less. So, that slowly that meters will oscillate in that voltmeter or meter. When meters oscillation is very slow, we can measure accurate value. Otherwise, if you have so much difference in the speed, no, slip will be very high. Then if difference is more, oscillation of meters also very high. Then it is difficult to point out accurate value, maximum and minimum. That is why we preferred always lowest, means here 0.5% is there. That is the best choice. Next, which of the following graph represents the variation of synchronous impedance of alternator? Synchronous impedance. Impedance is what? Voltage by current. Now, if you see here, that synchronous impedance, voltage by current variation, open circuit, short circuit case. So, it will be constant approximately up to saturation. After saturation, voltage will not increase, but current keep on increase, short circuit characteristics. That is why the ZS decreases from there. Okay. So, option this graph A means option A here, it will satisfy, ZS it is. Next, the speed of synchronous motor with reducing load from full load will be dash. What is the speed? With reducing load from full load will be dash. So, even you reduce the load or increase the load, so from full load it is reducing now. Whatever the load, no load to full load, synchronous motor always rotates at one speed only. That is constant, it will not change, remain same it is. Next, whenever open delta transformer is supplying its full load capacity, then each single phase transformer will be loaded by dash percentage of its full load. Generally, in delta, if you take 3 single phase transformers, when they are operating at their full load capacity, suddenly if one single phase transformer is damaged, it becomes open delta. Now, in open delta, what is the capacity of open delta it can supply? Just √3 times of one single phase transformer. Okay. So, the capacity of open delta is equal to √3 times of kVA rating of one single phase transformer, √3 V2I2. If you take one single phase transformer capacity is V2I2, √3 times we will get it is open delta capacity. Now, in open delta how many single phases are working? 2. Then in that one single phase transformer will supply half of that, no, means √3 by 2 of its full load capacity. What is √3 by 2? 0.866, nothing but 86.6%. So, one single phase transformer is supplying its 86.6% of full load capacity. Next, a single phase 20 kVA transformer has maximum efficiency at 80% of full load, and total loss at that time is 1280 watts at maximum efficiency. Calculate copper loss at full load condition. See, We know that at maximum efficiency, what is the total loss of transformer? 2 times of iron loss, no? 2 Wi. Then the 2 Wi value given as 1280 watts it is. Then what is the iron loss here? 1280 by 2 means 640 watts. This is iron loss, and copper loss also equal here, both equal now at maximum efficiency, both are equal. And this copper loss is at what condition? 80% of full load. But they are asking copper loss at full load, therefore copper loss at full load according to square of the current, 1 square by 0.8 square, 1 by 0.8 square into this is 640. Then if you simplify, you will get 1000 watt it is. This is the full load copper loss, 1000. Check it is. Option B is the answer. Next, in Scott connected transformer connection, the neutral is located in dash. So where we have neutral point? Because Scott connection mainly we use to convert 3-phase into 2-phase. So if it is 3-phase, which similar to star connection there, so definitely neutral will be there in that star, means then where is that neutral located? Remember, it is located in the primary of teaser transformer, and that neutral also divides the teaser transformer primary in the ratio of 2:1 ratio. Okay, in the teaser it is located. Next, a single phase 15 kVA 300 by 900 volts 2 winding transformer is converted into 900 by 600 volts auto transformer, then its kVA rating will be dash. Then if you draw figure, no, 900 is input side, this is 900, another winding 300. Then when we get 600 here, subtractive connection you have to take like this. This is 300 volts, this is 900 input side, and subtractive connection 300 volts here. Then 900, 600 series subtractive connection. Then what is the kVA rating of this? Don't use that formula whatever most of you know, that is for additive connection only. Then easiest one here, calculate the rated current of this 300 volt winding. According to data, what is the current in 300 volt winding? 15K divided by 300. If you simplify, we get 50 amps it is. Then this current is 50. Now here voltage is 600, therefore kVA rating voltage current 600 into 50, nothing but 30 kVA we get. Okay, in terms of kVA it is 30, option D. Next, the commutator of DC motor acts as dash. The commutator of a DC motor. So in a DC motor, commutator behaves as how it converts DC to AC, no? In generator it is AC to DC. So in a commutator it is inverter. Next, a 4-point starter is suitable mainly for the purpose of dash. 4-point starter. See, in 3-point we have a problem of not suitable for high speed control it is. Because when we do flux control for high speed, the 3-point starter automatically goes to off position. It is not suitable. That's why that 4-point starter mainly we use for the purpose of high speed control. Okay, remember this. Next, as the load decreased from full load, suppose previously full load, now load decreasing. Generally when load decrease, what is the speed of most of the motors? Increase. Okay, load decreasing, no, speed increase. But the speed of dash motor decreases here. Which one it is? Differential compound. We know that no load to full load, the speed of differential compound motor increase, that is the only motor. But question is what? The load decreases from full load. When load decreases, speed also decreases. That is only differential compound motor. Remember this. Next, during plugging of a DC shunt motor, which of the following terminals should be interchanged? In the plugging method, generally we interchange armature terminals, we have to reverse. Okay, armature only, but not field. Next. So these are the questions from total electrical machines we have in the examination of SSC JE.
Right, students. Now we will see SSC JE mega mock test power system questions. Right. This is the first question. Which of the following mission delivers active power by absorbing the reactive power? You can see here, any mission which delivers active power, any mission which delivers active power is called as a generator. So according to that one, the answer should be either A or B. Option C given motor,
Option D also given motor. And they are saying that it is absorbing the reactive power. Absorbing reactive power. So, P will be delivered by the generator some positive value, and it is saying that it is absorbing the reactive power. So, a machine can absorb reactive power. A machine can absorb reactive power whenever it is under excited. Whenever it is under excited. So, the answer will be under excited synchronous generator. That is one option. Or the induction generator also will absorb the reactive power by delivering the active power. So, the answer will be induction generator. Induction generator. So, the perfect answer is option B. It is not overexcited synchronous generator. Overexcited machines will deliver the reactive power, right? Next one. Two buses, bus 1 and bus 2 with voltages 1 at an angle of 30 and 220 at an angle of 0 respectively are connected through inductive medium. Then the active power always flows from. Whenever you are having two buses, bus 1 and bus 2, which are connected through an inductor, right? So, bus 1 voltage is 1 at an angle of 30, bus 2 voltage is 220 at an angle of 0. The active power flows from high delta to low delta. That is the direction of active power. Reactive power flows from high voltage to low voltage. This is the direction of the reactive power. So, active power always flows from high delta to low delta, that is from bus 1 to bus 2. Reactive power flows from bus 2 to bus 1, high voltage to low voltage. Suppose if you are having capacitive medium, in case of capacitive medium, if this is bus 1, this is bus 2, 1 at an angle of 30, 220 at an angle of 0, active power flows from low delta to high delta. This is the direction of active power. Reactive power flows from low voltage to high voltage. This is the direction of the reactive power. The reverse thing will happen in the capacitive medium, right? So, for this question, for inductive medium, active power flows from high delta to low delta, bus 1 to bus 2. The voltage and current through an element are 220 at an angle of 45 degrees and 10 at an angle of 30 degrees amperes. Then the nature of element is. So, whenever you are having one element, students, across this element, when voltage is 220 at an angle of 45 degrees and current entering into the element I is 10 at an angle of 30. Here voltage phase angle is alpha, current phase angle is beta. Whenever alpha is greater than beta, the element is called as lagging element. Right, you can see, you can calculate the impedance Z is equivalent to V by I. It is 220 at an angle of 45 divided by 10 at an angle of 30. It is 22 at an angle of 15 degrees. If you expand this one in rectangular form, 22 cos 15 plus j 22 sin 15. It is in the form of R plus jx. When an element is in the form of R plus jx, that is called as inductive element. Whenever element is in the form of R minus jx, that is capacitive element. So, it is an inductive element, that is a lagging element. Current lags the voltage by an angle of alpha minus beta, that is 15 degrees. 15 degrees is the power factor angle, right. The next question here, the rated voltage of the insulating system. Insulating system. The voltage across the insulator is always line to neutral RMS voltage. But whereas the design voltage is line to neutral peak voltage. The line to neutral RMS voltage is the, right, the rated voltage of the insulating system, right. Reheating in gas turbine. So, whenever we are doing the reheating process, so there is no that much change in the compressor work, right. There is no that much change in the compressor work, but the turbine output will be increased. That will increase the turbine work. So, in case of the gas turbines. Boiler rating is generally are usually defined in terms of. So, boiler rating generally we can represent in terms of horsepower, HP, or in terms of BTU, British thermal units, right, or we can represent it in steam output in kg per hour, steam output in kg per hour, right. So, we can represent in BTU, British thermal units, or we can represent in horsepower, or we can represent in steam output of the boiler, that is kg per hour. Gas turbines we are using in the aircrafts, right, or automobile units also we can use. So, but mainly we are using in the aircrafts. The hoppers in electrostatic precipitator are generally is in dash shape. The hoppers in the electrostatic precipitator are, they may be in pyramidal shape or conical shape, right. So, highly preferable is pyramidal shape. Pyramidal shape we are preferring. A nuclear power plant is invariably used as a, so we know that nuclear power plants are coal based thermal power plants, we are using as a base load power plant. We are using as base load power plants, right. When K is equivalent to 1 at an angle of 120, the value of K power 700 is, students, when K is equivalent to 1 at an angle of 120, K square is 1 at an angle of 240, K cube is 1 at an angle of 360, which is 1 at an angle of 0, means 1. K cube will be 1. Therefore, K power 700 we can write it as K into K power 699. It is K into K cube whole power 233. K cube is 1, 1 power 233 is 1. What is the answer now? It is K. The value of K power 700 is K, right. The phase sequence of the given system is, so to identify the phase sequence, rotate all the phasors in the anti-clockwise direction, students, anti-clockwise direction, and a stationary person standing here and looking like this. This person first of all meets A phasor and then C phasor and then B phasor. The phase sequence is ACB, but given is ABC, it's wrong, right. Suppose the person, if he is standing here, first vector he can meet is C and then B and then A. CBA is the phase sequence. CBA is the correct answer. It's not CAB. If the person is standing here and he is looking like this, first vector he can meet is B and then A and then C, BAC, right? BAC. So, both BAC and CBA both are correct. BAC and CBA. CAB is wrong. CAB is wrong. CBA is correct. BAC is also correct. Right, students? A shunt fault is characterized by, increase in current, frequency and power factor, increase in current, reduction in frequency and power factor. If you see, whenever shunt fault occurs, the current will be increased, right. As a result, the alternator speed will be decreased. When speed is decreased, as a result, frequency will be collapsed and the power factor will be decreased. The shunt fault can be characterized as high current, low frequency and low power factor. Reduction in frequency and power factor. Right. The skin effect in conductors is due to non-uniform distribution of current in it, and major portion of current is near the dash of the conductor. The skin effect always causes the current to be concentrated on the surface of the conductor, right. That is called skin effect. Because of skin effect, major current will be on the surface, less current will be at the center. Under voltage relays, low voltage is the problem of, low voltage always occurs for the loads or the motors. The under voltage relays are always used for the protection of the motors. Right, students? The material used in the liquid fuses right? Liquid fuses means in case of circuit breakers we can use SF6, right? And in case of oil circuit breakers we can use transformer oil, and in case of liquid fuses we can use carbon tetrachloride. Carbon tetrachloride, because of high dielectric strength we can use carbon tetrachloride, right? Which of the following circuit breaker has high reliability and minimum maintenance? So, high reliable and minimum maintenance circuit breaker is always SF6 circuit breaker. SF6 circuit breaker, very clean and neat and needs very minimum maintenance, and we can trust it. It is highly reliable circuit breaker. In a power plant, the reserve generating capacity which is not in service, but in operation, it is called as hot reserve. Similarly, the reserve generating capacity which is not in operation and it is in service, that is called as the cold reserve. See the difference between cold reserve and the hot reserve. Hot reserve is not in service but in operation, right? Which of the following types of wiring is preferred for workshop lighting? Workshop lighting, generally we are going for concealed and conduit wiring, right? And we can go for surface conduit wiring for apartments, that is buildings like that, right? The purpose of providing a choke in the tube light. Generally, the choke is used to induce high voltage. Generally. That is the major purpose. Along with that one, we can use it to limit the current, the starting current also. Right? To limit the starting current also, we can use the choke coil. Right? Also, the choke coil can reduce the corona effect also. If you take the major effect, we can go with the current limiting purpose, right? In electric discharge lamps, the light is produced by magnetic effect or heating effect or cathode ray emission. It is because of the ionization of gas. Or vapor. Because of that one, the light will be produced in the electric discharge lamps like sodium vapor lamps, right? D is the distance of a surface from a source. The illumination upon the surface will vary as. Illumination is always inversely proportional to radius square. Or the diameter square we can take, right? Or the distance square. In earthing, which of the following is referred to as waterman pipe? GI pipe is always called as the waterman pipe, students. Whatever GI pipe we are having, so that is called as the waterman pipe in the earthing, right? Earthing is necessary to protect against electric shock. Earthing is always necessary to avoid the problems of electric shock, students. Right, students? These are the questions we are having, right, students?
Hello everyone, this is Ramesh Pabba. In this I am going to discuss about the solutions from measurements and measuring instrument subject related to SSC JE mega mock test. Here is the question. In this, the ammeter is designed with the internal resistance of the ammeter internal resistance must be always very small. So therefore, what is the answer? Very low. If it is an ideal ammeter, it must be 0, but it is not mentioned. So simply ammeter means the internal resistance must be very low. Right? Now, second one, the range of extension of voltmeter is done with. In order to extend the range of voltmeter, what we require? Series resistance we require, as well as high value of series resistance required. So automatically here low resistance wrong, parallel wrong, here high resistance in parallel wrong. So automatically high resistance in series. So therefore answer is D. Right. Next one. A 0 to 20 ampere PMMC ammeter. Read the question carefully. Device given is PMMC. Connected to a 10 amperes which supply? 10 amperes single phase sinusoidal supply. Sir, PMMC reads DC or PMMC suitable for DC we say? That is, PMMC reads always average value. Therefore, if this AC supply is given, what is the average value of AC supply? 0. So therefore, simply for the given one, simply reads 0 value. Right. Next one. A 0 to 12 ampere ammeter. So therefore, full scale value is given, that is 12 ampere, and connected to 4 amperes of supply. Therefore, true value is given as 4 ampere. The percentage limiting error is dash when guaranteed accuracy error. So which is given? GAE is given as plus or minus 2%. So therefore, percentage limiting error equal to full scale value 12 ampere by true value 4 ampere into guaranteed accuracy error plus or minus 2%. 4 3s are 3 into 2, 6%. So simply plus or minus 6%. What is the answer? Option D. Right. Next one. MI instrument is used for, MI instrument is suitable for DC as well as AC. So automatically both DC and AC. Right. Next question. Which of the following is odd one out? What do you mean by this? 3 will be belonging to one type, one category, and 1 will be other category. That is what called as odd one out. PMMC ammeter. Yes, PMMC can be used as an ammeter as well as voltmeter, correct? MI voltmeter is there, MI ammeter is there. EMMC wattmeter. Yes, dynamometer type wattmeter possible. MI wattmeter not possible. So therefore, which is the odd one out? MI wattmeter is not there. So therefore, all these are present, but this is not present. Okay, not possible. Next one. Single phase AC power can be measured by, single phase AC power can be measured by using nothing but the single phase AC power can be measured by which of the following methods? Check it. EMMC wattmeter, correct. 3 voltmeter method, correct. 3 ammeter method, correct. Sir, in this EMMC method, of course, wattmeter, 2 methods are there. One is MC short connection or LC short connection, that is potential coil is on supply side or potential coil is on load side, that is correct. So therefore first is correct. 3 voltmeter method is also there, so second is correct. 3 ammeter method is also there, so therefore all are correct. Answer is all the above. Right. Next one. The primary current of CT is decided by, kindly focus more here. It is not as like primary current is determined by, primary current is calculated by. No, he is asking that primary current is of CT is decided by, means based on which parameter the primary current of CT will be there? Based on the load. So therefore, load current, if the load is changed, current will be changing, that current only passing through the CT. Just for idea purpose I am giving, suppose this is the CT primary, this is the CT secondary, and here ammeter, right? So this is the current I2, this is the current I1. Now this will be connected to some load, right? Whatever the load current is there, that is what we need to determine. Therefore, if the load is varied, load current will be varied, that load current only the current is I1. So therefore, primary current of CT is decided by load. So therefore, automatically load current is answer. If they are asking like primary current of CT is determined by or calculated by using IT based on the turns ratio, N1, N2, etc., we can use a formula. But he is not asking determined by, he is asking decided by. Right. Next one. A 100 volt range voltmeter has the sensitivity of, what is that? Full scale value is given as 100 volt or range is given 100 and sensitivity is 20 kilo ohm per volt. Sensitivity is 20 kilo ohm per volt. What they are asking, the resistance of the meter, very simple. Per 1 volt 20 kilo ohm is there, per 100 volt how much is the value? So simply RV is equal to 100 volt into 20 kilo ohm per volt. 100 volt into 20 kilo ohm per volt. So simply what we can write now? 2000 kilo ohm. See the option? Yes, 2000 kilo ohm. Right? Next question. Which of the following instrument has no controlling torque? Means the controlling mechanism like spring control mechanism is not present. What is it? EMMC wattmeter, yes, controlling mechanism is there, controlling torque. PMMC ammeter, yes, controlling torque is there. MI voltmeter, controlling torque is there. Power factor meter, yes, controlling torque is not there. Right? Next one. Two resistances are rated as 40 plus or minus 5%, R2 is 80 plus or minus 5%. These two are, what is the total percent limiting error when these are connected in series? Very simple. Total resistance in series connection is R1 plus R2. But what is the technique we know? Addition operation, we talk about value form. So simply 40 plus or minus 5% of 40. So simply 2. Right? Plus R2. 80 plus or minus 5% of 8, 4 over 40 plus 80, 120, and errors will be always add up 2 plus 4, 6. So therefore, this is correct, 120 plus or minus 6. Right? Next one. In a dynamometer wattmeter, the moving coil is the dash. Sir, current coil is anyway fixed coil. Potential coil is the moving coil. Low resistive coil is also current coil. What he is asking? The moving coil is dash. Answer is potential coil. So these are the questions from the measurement subject. Clear?